BC Calculus 3.3 Rules for Differentiation. All right, not fooling around. Let's do the rules for differentiation. So, number one, derivative of a constant. Constant could be 7, 8, 12, 10, whatever. So the derivative of pi, why not, is 0. How come? Don't forget what a derivative means. It is the slope, and a constant at, say, pi here, has a slope of 0. So the derivative is 0. Now the big one, n times x to the n minus 1. I should not say n. Yeah, I guess it could. Oh, right. The derivative of x to the n is n times x to the n minus 1. Sorry, getting a rule ahead of myself. So, for example, derivative of x to the third, take the 3 out front, subtract 1, 3x squared. You've already proved it. All of those limit as h approaches 0, f of x plus h minus f of x. Every single one of those obeyed this rule. So, practice. Pause this and try it. And I'll do it. Derivative of y is y prime equals 5x to the fourth. It's probably the most important rule you'll learn all year. Just absolutely huge. Used all the time. One of the few things I remembered from calculus 20 years later. If there's a number out front, like -2, we just include it in the process. It really doesn't matter. dy dx equals 4 times -2x to the third. And we will not do this intermediate step. We'll do just multiply them together and run, because this is going to be one of a 30-step problem. You don't want to spend a lot of time just doing simple derivatives. How about if we have them spaced out? No problem. F prime of x equals 9x squared minus 2. Done. What happened to the 1? d dx of 1 is 0. So just take the separate derivatives. It's a sum or difference rule. It's kind of silly. So then I can give you problems. Where are the horizontal tangents of the curve y equals x to the fourth minus yada yada? Well, horizontal tangents mean slope is 0. So dy dx equals 4x to the third minus 4x. Done. Set that equal to 0. X times x plus 1 times x minus 1 equals 0. We will find horizontal tangents at x equals 0, x equals -1, x equals 1. So, horizontal tangents, huh? That means we can graph this and find it. X to the fourth minus 2x squared minus 2. X to the fourth minus 2x squared. I always do that. X to the fourth minus 2x squared minus 1. X to the fourth minus x squared minus 2. My bad. Not that that'll matter, as you can guess. That doesn't really make any difference. But graph it. We can see there's horizontal tangents here, here, and here at -1, 0, and 1. What did we find? -1, 0, and 1. Now I know you're going to be surprised, but we get a little bit more complicated. What if the functions are being multiplied? They call this the product rule, and it's written up down here. But basically, keep the first one, take the derivative of the second one, plus keep the first one, second one, keep the second one, take the derivative of the first one. Now you can finish there, but let's do some like terms here. Let's put it in order just to be proper. Now I'm going fairly quickly because this is a long video as it is, and I may have made some mistakes. So some people say, well, why don't you just distribute this one out over here, see where it goes? And I say, hey, you're right. Let's try that. And something's bothering me already. Didn't take long. Told you I made a mistake. So keep the second one. Derivative of the first one is just 2x. No, I did that right. All right. So what's bothering me is that I don't know where this extra derivative is coming from. So I'll give it a shot. See if I get it. Atom, x to the fifth. Sorry, I'm still bothered so much I want to try it again. There it is. Radar was going off. 2x to the fourth. That's the reason we should check our work. Okay. X to the fifth plus 3x squared plus x to the third plus 3. Take the derivative here and we would get 5x to the fourth. I'm going to do the third term next to put it in order quicker. 3x squared, done. So I found a mistake somewhere in here. Yep, didn't take the derivative here. Holy moly, I'm rusty. Good, 6x. They're the same. I will or will not do this again later, but I recommend doing problems first few times, a couple different ways. Show yourself that they work. We just proved it. You can also say there's a quotient rule, which is a real pain. It takes some serious getting used to. So your V is on the bottom. Sometimes it helps early on to say V. And my U always has a little extra curl to it. And F prime of X is going to equal X to the fourth on the bottom. Keep that one the same. Take the derivative of the second one. Minus keep the top one the same. Doing my best not to screw up again. Times the derivative of the bottom one, 2x. A little bit of algebra to do here. Looks like those cancel. Huh. Now I gotta check my work. There we go. So I'll check my work now by doing it the other way. I rewrote it so that it's a negative exponent, and now we just go back to the product rule. You just leave the first one alone, take the derivative of the second one, Negative 2x to the what? Subtract 1, negative third. Weird. Plus x to the negative second, 2x. Taking the negative 2 here, distributing it, putting the x to the third on the bottom, multiplying another x up top so that I have a common denominator. I get 2 over x to the third. My apologies for skipping the steps. If you want to do that the long way, by all means. How do we do? 2 over x to the third, 2 over x to the third. I remember when I did this a long time ago that I preferred to do it with the product rule. I just did not like the quotient rule. I just write it as a negative exponent and I'm happy. I can do it and I'm good at the algebra. I actually answered this question up here. Well, not that question. I answered this question up here, and the derivative of this is just, as you saw, negative 2x to the negative third, negative 2 over x to the third. Can we check this graphically? And the answer is yeah, we could do a derivative and write it all down. I recommend you try that on your own. So 2 more things. These are just extra problems. What is y prime of 2? Well, if this is that, let's write it out first. Y prime equals, I have to practice these more because I'm not fast at them, u times v prime, I'm going to avoid the dots because they'll look like minuses, plus v times u prime. Y prime of 2 equals 3 times 2 plus 1 times negative 4. This is just giving you a chance to practice. It's, I don't know what to call it, just another example of how you could use it. And we can find more than one derivative. We just keep going. Y prime equals 3x squared minus 10x. Y double prime equals 6x minus 10. Y triple prime equals 6. And y to the fourth. I feel like they do that differently, so I want to double check real quick. Yep, put a little parentheses around it. Equals 0. So that is the first 4 derivatives. Usually the max derivative we go to is third because of the whole displacement, velocity, and acceleration, but that's our next lesson. So that's it, and boy, that's a lot. Happy mathing.